Any questions from yesterday's class with respect to the predicate framework in particular? Any questions? Anyone? Everything clear? Did you have a chance to look at it, revisit it? You can ask me if there are any, if you have any questions. Yeah, I gave these two questions yesterday. Yeah, we can discuss the searching in mountain array once. So what is your, how did anyone solve the searching in mountain array question? Yeah, Rashmi, how did you solve it? Can you unmute and speak?
First, I found the peak element. If that element which we are searching in the is greater than the peak element, then return -1. Else if search in left part and right part separately.
Yeah, that's basically the approach. So peak element, I think we discussed in the class, right? How to find the peak element. And after that, you can search in both the halves. Yeah, but you are still able to access the elements of the array, right? That's what you need. You don't need anything else in your binary search, correct? You just need the you just need to reference, you need a particular element at a specific index, which you can always find out through that get function that they have, right? Sorry. Like, does it change the dynamics of binary search? No, right? You're not looping through the array, or even if you are looping that also you can get to it, right? It's basically the same. They just that they've given you an API to so it is mostly because of security. So if you have data that you don't want the particular want any external outside public to change or modify, you typically provide. So this is one programming practice that is followed. So what Shaurya is asking is, if you guys had a chance to look at how to search in a peak array, search in the mountain array question, they have provided you APIs, right? APIs are nothing but an interface for for finding out for obtaining something. So they have given you getter and setter functions, getter functions for getting elements at particular indices, right? And the typical reason why they do that is because of security. So they, if you don't want the outside public to change the array or modify the data structure, because it's your data, right? It can be critical data and you don't want any Tom, Dick and Harry to change that data for you. So then typically what you do is you provide getter methods. Getter methods are nothing but an API, which a function call basically, which you can call to access to access a data. So this basically shields, yeah, it's like a read-only data. It basically shields your underlying data structure or whatever data you have from modification to the outside public, right? So whenever you want to, it's almost like they have provided you a security or a watchman here, and you have a data. So this watchman is protecting the data. And this is the data. Watchman is protecting the data. So you as a person, whenever you want something, you tell the watchman, hey, give me this index. So the watchman will go walk and get you that index instead of you directly going and changing, because then you can do anything with the data, right? Which they don't want. So that's the reason they do that. But yeah, that really does not affect, from a purely question solving standpoint, that really does not affect the algorithm or the implementation. Okay. Shall we move on? Any other questions from yesterday's class? So you will be able to do this, right? As Rashmi, I guess, Rashmi was telling that what you have to do is, if you have to search in a mountain array, you can get the peak, right? And we already discussed how to get the peak using the predicate framework. Once you have the peak, you can search for 0 to peak -1 and from peak +1 to n -1. You can apply binary search here, right? Because again, you can define a predicate which can give you f star t star. For this half also, you can define a predicate which can give you f star t star, right? Searching in the sorted rotated array is also similar. Nothing big, no big deal about it. You find the minimum and then you can basically search according to the range. If your data is in this range, you search in this half. If your data is in this range, you search in this half. Yeah, that's one way. There are complicated ways of doing it, but yes, this is the which question, Aman? You can compare it with the high and the low, yes. But what will you do after that? Maybe you can unmute and speak.
So after comparing the mid with the high and the low, if the mid is less than the high, that means element is in the lower portion. So the right side of the mid is sorted array. And if our mid is greater than high, that means our element is in the upper portion and the
Greater
left
than
side of
high, how do you know the high?
like the A of high. If we like,
This
we know the.
You're talking about comparing it with an minus 1 and a0.
Yeah, an minus 1 and a0.
Okay, so if
So
it is greater than a0, then
yeah,
you
and
know
less,
that, okay,
it is,
then you know that it's in this half.
yeah, and if it is less than a high, a of n minus 1, then it is in the lower portion and the right side of the array is sorted.
No, but what about the other case? What if it is less than a0?
What if it is less than a0, then the portion, then our element will be in the lower half. So the a mid would be less than a n minus 1.
Well, element can be here or it can be here, right?
Yeah.
So
So
how
we will
it's
check if it is equal to a0. If it is equal to a0, we can return it directly.
okay? If it is not,
then we can like just use a mid less than a high as our predicate and just compare it, apply the binary search.
yeah, okay, that also is fine. Were you able to get it accepted?
Yes, sir.
Yeah. Okay, let's start for today. H index we can discuss later on. H index as well as the Chinese, what was that envelope question, right? There was some, so we can discuss those later. Today I want to start with another class of problems that can be solved using binary search, which are nothing but optimization problems. So we want to look at certain, this will be a slightly more advanced topic. This is not really, this is moderate difficulty, you can say. But yes, if you follow along, I guess we will be able to storm through this as well. So we are looking at optimization problems which we want to solve through binary search. So typically those two types of problems can be solved using binary search. First are explicit search questions, which we did yesterday. We did a lot of practice with explicit questions wherein there was an explicit need to search something and there was a search space which was given. Today we will look at another class of problems which can be solved using binary search, which are optimization problems. And so basically in optimization, and we will look at how we can achieve that. And typically in these kind of problems, what happens is the search space is not really given to you. And you have to come up with a search space on your own. You have to define a search space on your own and then search it there. Okay. This is just information that I'm giving you. So what kinds of optimization problems can you solve using binary search? That's the first thing that I will tell you. And then we will look at a problem and dissect it and and look at it step by step, how to go about solving that particular problem. So what kind of optimization problems can we solve? Typically, you will be told to optimize a certain quantity, a certain variable, or what does optimization mean? Optimization means to find either the maximum or the minimum of some quantity. Okay. So these optimization problems will tell you to find the maximum of or minimum of a certain variable or a certain item under some constraints. So there will be some constraints and you will be told to maximize, minimize a certain item. These constraints will typically be, so let's say this item that you want to maximize or minimize is X. These constraints will typically be of this type or this type. So basically, you will be given some function of that particular item and you will have to ensure that when you are maximizing or minimizing that item, that function remains well within a certain upper bound, or that function has to exceed a certain lower bound. Can you mute Aman? I guess is it you or is it someone else? Yeah, thank you. Okay, so this is at a very high level, what kind of optimization problems we can solve. Let's look at it with an example straight away without really, and things will become clear to you. So try this question, a simple question we will do. I will just paste the question in the chat. This is the question. Take your time, go read it. Utkarsh, hi, did you join today? Hello, Utkarsh. Doesn't look like you've joined through the audio. So you can, there's an option in the top left, in the bottom left corner of your Zoom screen, which will ask you to join with your computer audio. You can click on that and then I guess you'll be able to join the meeting. Currently, it does not look like you've done that. Utkarsh, are you able to hear me? You can type yes in the chat if you are. Okay. So I will tell you the question. So just follow along with me. You will not be able to do this question. That's fine. Okay, so just follow along with me. What this question is telling you is you are given an array of numbers. You are given an array of numbers, some numbers. At any step, and you are given some threshold. Okay. Yeah. You're given a threshold. At any step, what you can do is you can pick up any random number and divide. Let's say you pick 2. Then you can divide all these numbers with that number that you chose and sum them. So when you are dividing it, you have to take the ceiling of the division. So 3 by 2 will give you 2, not 1. Okay. So take the sum. Here it will be 3 plus 2 plus 3 plus 4 plus 4 plus 5. 13, 16, 19, 21. So similarly, you can divide it by 3 also. You will get some sum. This is S1. Let's say you divide it by 3, you will get some sum. Let's say you divide it by 4, you will get some sum. So when you divide by numbers, you will get some sum. You have to find the smallest such number with which you can divide such that the resulting sum that you get, Si, is less than equals the threshold. Do you get the question? Three by 2, Akash, will be 2. We are taking the ceiling. It's given in the question. Others, just take your time, read it. So one thing to observe is that as you increase your number, as you increase your x with which you are dividing, the total sum will decrease. Yeah, Akash, I'm just telling you that take numbers and divide all the elements of that number, elements of the array with that number, and take the sum. Okay. So when you're dividing 3 by 2, take the ceiling of ceiling. So what is 1.5 ceiling? It's 2. Okay. 2.5 ceiling is 3. So round it up to the nearest integer, to the next integer. So divide it by number, sum it. Whatever sum you get is one sum. So let's say if you divide by 2, you get S1. Divide by 3, you get S2. Divide by 4, you get S3. You have to find the x for which, if you divide you have to find the minimum x for which Sx is less equals t. So first of all, let's see the pattern in the question before we conclude or go about solving this question. First of all, I will give you some intuition on this question. As you increase x, the number with which you are dividing, don't you think that the total sum will decrease? Correct? Everyone follows this? As we increase x, the total sum will decrease. Correct? So if this is the number line and this is the threshold, as you increase x, so for the smallest x, that sum might be somewhere here. Correct? Very large. And as you keep increasing the x, you will start approaching from the right to the number of the number line, right? So here you are increasing the x. So there will be a point when you will cross the threshold, just cross the threshold. And the x for which you will just cross the threshold is what you have to return. This will be the minimum x for which Sx will be less equals t. Right? Do you get an intuition for this? Should I repeat? Everyone is getting an intuition, right? If you don't, please let me know. I can repeat. Yeah, Karan, I can repeat. So see, this you understand, Karan, right? When I'm increasing x, your sum will decrease. This you understand, right, Karan? Because you are dividing by larger numbers, so the sum will decrease. So now see, this is the sum. Okay, let's do it with a graph. This is X and this is the sum. Okay. As you increase X, your sum will increase, correct? Your threshold is somewhere here. So your sum is increasing as you increase X. There will be an X there will be an X1 for which the sum will be, the sum will decrease. I drew the wrong graph. So see this. As you increase X, your sum will decrease, correct? It will be something like this. So there will be an X. So this is your threshold, let's say, for which this is the X. So there will be an X as for which the first X for which the sum will become less than the threshold, correct? And this will be the minimum X. And this is what you have to return, because any X greater than this, the sum will be less than the threshold, but the X is greater than this, right? And for any X which is to the left of this, the sum is greater than the threshold. So the constraint will not be satisfied. Right? Karan, do you follow? And what about others? People who had issues? Rahul? Aryan? Yeah. Yeah. So this is the intuition, basically, just the feeling. Okay. Now let's look at the first thing when I'm given this question is I will look at the pattern in the question. So what is the pattern in the question? This question is telling me to find the minimum X. So obviously it is telling me to optimize a certain variable, correct? So it definitely is an optimization problem. It is telling me to optimize a certain item, provided some function of X is less equals threshold, correct? What is this function? This function is the sum of all the elements of the array, right? So this is the pattern that I was talking about, where binary search can be applied. Basically, you have to optimize a certain item under some constraints. The constraints are that your there will be typically a function on that particular item or that variable, and you need to make sure that that function is upper bounded or lower bounded. Either it can be this or it can be the other way, right? So this is the pattern. First of all, do you understand the what of this pattern? Like what kind of questions can be solved using binary search? With what kind of optimization problems? Even within optimization problems, there are like a lot of optimization problems, right? Only one certain types of optimization problems binary search is applicable. This is one such optimization problem. And I just told you the pattern. If there is any question here, please let me know. So then we will systematically approach it. So the first thing you have to do, if you have made up your mind that this question can be solved using binary search, is that you have to define a search space for yourself. Yeah, Suraj, I was just telling you the intuition. So you understood the intuition, right? That as X increases, the sum decreases. So there will be a point when the sum will be less than the threshold, and you have to give me that X, the minimum, right? So I was just telling you that there are only a certain class of problems which can be solved using binary search, and they are optimization problems. The pattern is similar to what is here. Here, if you see, you have to optimize X, provided that your some function of X is upper bounded by some threshold, right? So this is the pattern. Okay. Yeah, nothing else. So now if I have made up my mind that I want to solve this question using binary search, the first thing that I will do is I will define a search space for myself. Then the next thing I will do is I will trim my search space. Then I will come up with a predicate. And finally, I will apply binary search. These are the steps that I will follow to solve any question, any such optimization question. So let's see. let's define a search space first. So here, if you see, you have to search for a number, right? That number can be anything potentially, right? From 1 to infinity, right? This makes sense because you can divide, that's basically explicit in the question. Then the second thing, so this part is clear, right? How I define the search space to be 1 to infinity, because it's told in the question, right? Can I get an acknowledgement so far, or like for whatever I have spoken so far? Yeah. So now let's trim the search space. So trimming the search space is basically nothing but in this range, in this trivial range that I have defined, I want to trim it to a certain range such that this part and this part of the search space is either redundant or not applicable. I will give you an example in this question, how we do this. So think about the upper bound of the search space. So there I tell you that think about the maximum number of the array, the largest number of the array. If you divide it by the array, you will get n, right? The sum. Do you understand? Because every number will be less than the maximum. So if you divide it, it will be less than 1, and the ceiling of that will be 1. So it will be 1 plus 1 plus 1, so on till n times. So the total sum will be n. If what I told you is, if I take an array and I divide numbers of this array with the maximum element of the array, then the sum I will get is n, right? If I divide it by max plus 1, max plus 2, max plus 3, the sum will still be n, right? No matter whatever number I divide it with, the sum will still be n, correct? So this part of my search space, the part which is to the right of the maximum number in the array, is redundant. I don't need to search here. Okay. Is this argument clear to everyone? How I trimmed my search space from the right? If there is any question, please let me know. And for the lower bound, I will have to start from 1, because any number I cannot trim basically. I can check for the minimum, but I can, there is no way I can trim the lower part. So my search space after trimming is basically 1 to maximum of AI. So I have to search in this search space now. I have to search for that X in this search space. Okay. Now let's do the third part, which is defining a predicate. So now I know that my search space is from 1 to max of AI. So now I want to define a predicate for this. So tell me, how can I define a predicate? Use the same intuition that I gave you. This is the range of X, right? So this is X on the number line and your sum. So there will be a point when it will cross the threshold, right? So can I have my search space in such a way that exactly around this threshold, for this half, the sum is, the predicate on the sum, the predicate evaluates to false, and for this half, the predicate evaluates to true. The predicate will obviously be related to the sum in some way. Can you think?
Sum greater than target.
The sum, you're saying sum of X greater than the target. Okay. And you will have to find the last F then, is it?
Yes, sir.
Yeah. I use sum greater equals the target if you want to do. Will it be right? What do you think? It is not right.
Yes, sir, I think we have to find the first true.
For some greater than the target?
नहीं, some less than equal to.
No. What is your predicate, Simran?
Sir, when sum of x is less than equal to target.
Sum of x is less equals target is what you are taking the predicate. Then you are reducing it to t star f star. Right? You can do that, but I generally prefer f star t star. Let's follow one convention. Okay. We've been doing questions with f star t star.
Okay, sir.
Okay. So let's define a predicate accordingly. Can anyone tell me why sum of x greater equals target is not right? If we take sum greater equals target and we find the first true, is that correct? It's not always correct, right? Because if the sum is equals to the target for that true, then yes, you are good. But if the sum is strictly greater than the target for that true, then that is not the answer, right? The answer is the previous one. Right, Ayush? Do you get what I'm trying to say? Yeah, last fall should work then. Yeah, you can do that, but you will have to take care of these cases basically. In the sanity check part, you will have to take care of it. But if we do this, then we can blindly just say that the last F, I can just check the sanity that the last F, the final F is the answer. If that is an F. If it is all T's, then basically I don't have an answer. Right? What about others? Why only 4 or 5 people? Clear? Simple, easy peasy. So yeah, that's it. So you do that then. And then you can just write the code for the last step. Shall we code it quickly? Which part, Akash? Do you want me to explain? Why last F? Because last F, Akash, is, so if you take this predicate, what does F mean? F means Sx less equals target, right? And you want the last F. Correct? So think about it in this way. Others, can you try it on your own? Meanwhile, while I'm explaining this to Akash, can you try the code? I will do it, but yeah, can you do it on your own meanwhile? Yeah, just try it. So Akash, see, if you are using this predicate Sx greater than t, then for small x, right? For small x's, Sx will be greater than t, right? And for large x's, Sx will start becoming less equals t. Right, Akash? Yeah. So the first, for this F that you are talking, this is basically what you want, right? For this, you have Sx less equals t. And you want the smallest, so this is the first, right? This is x is increasing. Yeah. With this predicate, this is how you do it. If you do a predicate Sx less than t, then basically for small x, Sx will be greater than t. So you will have to do Sx less equals t then. Yeah, Abhishek, we are following f star t star. So for that, this will be the predicate. That's my bad. Yeah. This won't be the predicate for that. Less equals. It won't be less than. It will be strictly less than. Less equals. And so for Sx less equals t, as you increase x, it will still be false because sum will be greater than t, and there will be a point when the sum starts becoming less than or equals to t. Correct? And so here you will have to find this, the first t. So if you want to do it by f star t star, this is the predicate, and you have to find the first t. If you want to do it by t star f star, this is the predicate, and you have to find the first f. Am I right? Or did I mess up something? Abhishek? You will have to use a strict less than, right, here? Yeah. Yes. So if I use Sx strictly less than t, then the first t will be, you have to find,
So we have to use equal to.
you will have to use equal to, and you will have to find the last f, right? Not the first t. That's the mistake. Or the first t. What is it? If you are doing this, tell me.
The first T only.
First T only, sir.
First t only, right? I was right.
Yes, sir. I think so. First.
No, but for the first t, your sum will become, yeah, the first t. Yeah, equality and first t. I think I wrote it correct only, Abhishek.
Yes, sir. At equals, we will get the same sum.
Yeah.
That's our target.
Yeah. Yeah, this is right, Abhishek, whatever I wrote. Right? Do you follow, or do you have any questions? Yeah. Okay. Akash, is it clear? Both the predicates? Like if we'll be doing this because we are doing f star t star. No, for inequality, you cannot say that first f will be the answer. For inequality, the last f or the first t both can be the answer. It depends, right? Because if you use s less than t, then the first t will be greater equals t. So if it is strictly greater, then this is the answer. But if it is equals, then this is the answer, right? So you cannot just say that for s less than t, last f will be the answer. Yeah. Let's quickly code it without any further wastage of time. So it's always recommended that you write modular code. So I will first write a function to compute the sum of the, given a divisor and an array, I will write a function to compute the sum first. So let me do that. Int compute sum. This will just take an array and a divisor and give me the sum. So how do I do this? I can this is nothing but s. If you want, I can rename it to s. Let's rename it to s. So I will start from 0, go all the way till n, and I will have a sum variable. I will divide num psi by the divisor. But will that be all? I can take the seal, but will that be all? I will have to do something else also here. Is this correct, or is there something that's missing? The smallest divisor code. Anyone? Are you coding on your own, or are you seeing this screen? If you are coding on your own, I can give you time. If you are seeing this screen, then yeah. Okay. Okay. Take your time. I can give you maybe some time. You can try it on your own. Yeah, is everyone coding? There's no one sitting idle, right? If there is anyone sitting idle, please let me know. Yeah, just try it. I will give you 2 to 3 minutes and then we can discuss.
Sir, what exactly is int s?
This is a function that returns integer. S is the name of a function.
Okay.
Let me know, we can start discussing. You can see my code then. Which ones have you? Why will it be a nested function? I just have to compute starting with the divisors. Because I wrote it within a function in my code. Have I redeclared S anywhere? I have not redeclared S anywhere, have you, right? So, okay, now I think let's start. Can you start? Where is nested function, Savio? I don't get your question. Can you unmute and speak?
The S function is nested inside the smallest divisor function, right?
The S function is nested. Oh, that's my bad. Yeah, I'm sorry. Yeah. Sorry, that's my bad.
Okay.
Yeah, sorry. Can you explain when do we use functions and when not? So whenever you have a portion of the code that is independent by itself and you have to reuse it again and again, you should typically write it in a function. So this we will use to compute the predicate, right? Every time. That's why I have created a function for this. Right, sorry. Generally also it's good to modularize things. You should always predict, like have a modular codes. All right, are you ready? Shall we start? Or do you need more time? Yeah, let's start. So everyone, please see this. I will, please see. Yeah, please see. See my code. I will start the code again. I am assuming you didn't follow anything. So I will first write my S function. Okay. S is nothing but I will compute the sum. Given a divisor and a vector, I will compute the sum first. So let me do that first. So for that, I have to loop through all the elements of the vector or array, and then I will have to divide num_i with divisor, but I have to take the ceiling also. So ceil is a function which gives me the ceiling, and I can return the sum. Is it all, or is there something that's missing in this function? Akash, this ceiling is a function that takes a fraction or a decimal and rounds it up. So if ceil of 2.5 is 3, ceil of 2.7 is 3, ceil of 3.1 is 4. Okay. So my question to you is this enough, or is there is something wrong here?
We're dividing an integer by an integer, right? So they'll
Yeah.
again give an integer.
Yeah. So we need to typecast one of them to a float, so that this resultant division is a float or is a decimal. Do you get this? If I just divide 5 by 2, I will get 2 because both are integers. So the compiler by default will convert the result also to an integer and return. So if I divide 5 by 2, it will be 2. But if I divide float 5 by 2, then it's 5.0 by 2, which is basically 2.5. You can also declare divisor to be float. Divisors are typically integers here. You can typecast, yes. Yeah. If you want this, basically it will then, right. This is fine. Everyone understands F. So then let's get to the meat of the code, which is doing the binary search. So my search space is 1 to nums of max nums_i, right? So let me first find the max. So I will do that first. So I will say max num is int min. I can start with the smallest. How do I find the max? Right? This will give me the max. Now I can apply binary search. Let me just apply binary search on this. I will write a function for this. From 1 to max num for this threshold. So what will I do? I will have a mid. So is everyone with me so far? Are you getting what I'm doing here? All these modularization function, finding the max, everything. Int min is, Tanya, the lowest possible value of an integer. So if I assign max num to be the lowest possible value, then the first time I compare it with any number, that number will become max, right? So that's why I'm doing it. So that from the next number onwards, my comparison is correct. Do you
What would be
get?
the value of int min here?
Depends on the compiler. You can print it out, but for 32 bits, it is, I guess, minus 2 to the power 32. Right? Yeah. Tanya, do you get this? What I did? This is a very standard way of finding the mid. Now finding the max or minimum. If you have to find the minimum, initialize it to int max. You can initialize it to 0. Here it will work because the numbers are all positive, but had the numbers been negative, then 0 wouldn't have worked. Yeah, you can take max as a0 and then start from 1, that loop. Yes, that's fine. Or you can start from 0 also, it's fine. It's just that if the array is empty, then this will handle that also, this part. But otherwise your key will return a seg fault. Okay, so now I am writing the main crux of the binary search. While low less than high, I don't know how to find the mid. I will come back to it, but let's do the decision making first. So if predicate, I know what was, okay, let me comment that. So it was f star t star. My predicate was sum of x is greater equals is less equals t, the threshold, and I have to find the first t. This is what I had to do. So I will just evaluate the predicate as nums divisor is mid, and if this is less equals threshold, then this is a true, right? So I have to keep my true. So I can do high is mid. Else, if it is a false, I can skip the f. So I will do low is mid plus 1. So this will dictate the choice of the mid. So mid is the low mid. And now once I come out, I will have the remaining. And in the question, you see that it is guaranteed that there will be an answer. So I can simply return in. I don't really need a sanity check also here, because it is guaranteed that there is an answer. So I can straight away return low, and that's the answer. Oh, where is the syntax error? Line 37. Oh, I just put it in the other editor. Cool. You can stare at the code for some time if you want.
Sir, what exactly was the issue that you rectified in the return statement?
I instead of passing nums, I had declared it.
Okay.
Syntax. Can you explain the max num? Yes, I can. So I need the maximum to be stored in the maximum variable psi. So what I did was I initialized it to the smallest value possible, which is int min. And yeah, Akash, I'm coming to that. I read your question. So I initialized it to the smallest possible min, and now so that I am keeping a running maximum, Akash. So till I, whatever maximum I have will be stored in maxnum, and I'm comparing that with the current number. and updating my maximum. Right? Sai, is that right? Yeah, that's it. Akash's question is, please explain. I have just returned. This function will return an integer, right, Akash? I just returned it. You can do I mean, if you want to do, you can do an int temp is equals to bs nums 1 max num threshold, and then you can return bs. You can return temp. That's also fine. Okay, I just returned it because it is that function returns. Yeah. Sorry, the if statement in binary search, this one. So this is just the predicate. So this is the predicate, right? We decided upon this as the predicate. So I just evaluated my predicate on that. And if it is true, then I have to keep it. This is a function. This is a function that computes as, so it's taking nums as a parameter. I need that nums, right? Otherwise, how will I calculate the sum? Yeah, it's just a way of. Okay, everyone cool? Do you get an idea? Are you getting a hang of what this is? Yeah, we will discuss the time complexity. That's the next thing. So what is the time complexity of this? This is an order n, right? This is order n. What is the time complexity of BS, this function? N log n. Binary search is not log n, Gaurav, because every time we are finding the predicate, that predicate, this is not constant time, right? We are not finding the predicate in constant time. This is taking n. So one loop is taking n time, and how many such loops will run? Log n loops, right? The number of loops will log n, because that's how binary search is. You are reducing your search space by half every time. So the total number of iterations in this while loop will be log of n, and every loop is taking n time. Why? Because this computation is not in order 1. This computation is in n time because of this loop. So this overall complexity is n log n. So this is n log n and this is n. So the overall complexity is n log n. I mean, you can paste your code in the Slack channel. So we will see and people will help you out, right? Okay. Yeah. Cool. Is everyone fine with the solution as well as the complexity? Should I double click on any of it? Do you have any queries? Just act and we can move forward with the next question. Hello, hello, hello. Are you there? Yeah, clear to everyone? Karan, is this cool? Akshay, are you there today? Okay. Yeah, looks like Akshay is not here. Savio, it's clear, right? Complexity should be n into 2 log n. Why do you say 2 log n, Suraj?
So n square log n.
Why is it n square log n?
So because n log n is in the binary search part and the order n is in the.
Yes, but are they multiplying? So you are taking n time for this and you are taking n log n time for this. So what is the total time? N plus n log n.
Okay.
Right? N plus n log n, and which is bigger? N log n. So you can upper bound it by n log n.
Okay. Okay.
Yeah. Let's do another question, similar but very interesting, which is Try this question. So how do we approach this question? Yeah, will you be able to do this? Can you solve this as well as an example? Yes, we will do this. I'm just asking if you can do it on your own. So what is the question telling? The question is saying that you have an array of numbers and a target value. Return a target integer such that you change all the integers larger than value to be equal. The sum of the array gets as close as possible to target. Okay. So what the question is telling you is that you have an array of numbers. Okay. You have some numbers. Let's say 5, 7, 10, 12, 9, 15. Let's say these are the numbers in the array. And what you are doing is you can take any number. Okay. We will come to the search space, Mantavya. So you can take any number and let's say you take 6. So what you will do is you will replace all the numbers which are greater than 6, greater than, right? Not equal, larger than, yeah. So you can, you will replace all the numbers greater than 6 with 6. So this becomes 6, 6, 6 and 6. And this sum will be one such sum, S1. Similarly, you pick up another number, let's say 4, you will get another sum S2. Pick up another number 3, you will get another sum S3. So for all these sums, you have to give me the largest sum which is less than or equal to that threshold that is given. So first of all, see this intuition that as you increase x, what happens?
Some will also increase.
Will it? Some will also increase. Can you prove this? Why?
Yes, sir. Like we have a counting from 1 to 10. If we take like number 6, then all the numbers above 6 like 7, 8, 9, 10, they will reduce to 6. Then the last is last 6 count sum is 24. And then when we increase change our x like threshold value to 2, then the value is greater than 2 from 2 to 10. It will not more than 20.
But you have to prove this formally, right? The problem is that, yeah, Ankit, I am just saying that, first of all, do you understand the question? Can I have X? Can I see whether people are with me or are you solving it on your own? Right? You are following. You are in the class.
So shouldn't we calculate absolute difference as it is mentioned in the question?
You can calculate the absolute difference also. It can be greater than t. We will get around that. Yes, I mean, yes, ideally you want this, you want to do this. Like absolute value should be maximized, right? This is what you are saying. Right, Suraj?
Yes, sir.
Yeah, this is what we will get around this. We will have a Sx can be greater than t, but just think that around t you will have to find the first Sx which is less equals t and the first Sx which is greater than equals to t, right? Only these two will be your potential candidates, correct? So you can either do two binary searches, or you can just find the first one and take this and take this plus one and check the absolute difference for both of them and return the minimum, right? So my approach, what I'm saying is, what we will be doing is we will be finding the first Sx which is the largest Sx which is less equals t. Okay, if we find that, then we can do an Sx plus 1. That will be that Sx will be greater than t, correct? So I will then, my answer will be minimum of t minus Sx and Sx plus 1 minus t. This will be the answer, right? Does this make sense? Yeah, I can repeat. So what I'm saying is, do you understand the question first, everyone? That you have array, you can replace numbers greater than a particular x and you will get some sum, right? And you have to find the sum for which the absolute difference between that sum and t is maximized, is minimized, correct? This is what you have to do, right? So for solving this, what I am saying is I will solve the largest x for which Sx is less equals t. Okay, let's say that is S1. Now what I will do is Sx plus 1 will be greater than t, right? So because this was the largest x for which Sx was greater than less equals t. So S of x plus 1 will be greater than t. X plus 1 is in the denominator, right? So I will take S of x plus 1. Let's say this is S2. And I will simply take the minimum of S1 minus t minus S1, comma S2 minus t. Will that be the answer? right? So my goal is to find S1 first. If I am able to find S1, then I am able to solve this question. Right? So far, so good. So now, to give you an intuition for this problem, I want you to tell me what is the behavior of S as X increases. So on this graph of X versus S, how does S change? Why? Can you prove this? Yeah, but why? Do you understand why this is not a trivial proof? See, it is not a trivial proof because let's say you take two x's, x1 and x2, such that x1 is greater than x2. So for x1, you will replace, let's say, this half. This entire half part you will replace with x1, and this entire thing will remain as it is, right? For x2, you will be replacing this part, correct? And this part will remain the same. So for x2, you have replaced more number of elements than x1. Hence, this is not a trivial thing to prove. That just because x1 is greater than x2 does not, you cannot just say that S will increase or S of x1 is greater than S of x2. Do you understand what I'm saying? So it's not trivial to prove, but yes, this holds true. I can tell you. Can someone prove this for me? So for proving this, just take 3 halves, nothing else. Very simple proof. Take 3 halves. So when, let's assume the case when you are substituting x2. So you have this half, let's say this is A1, this is A2, and this is A3. A1, A2, A3 for x2 and B1, B2, B3 for x1. Okay. So the sum for x1 is, S of x1 is A1, A2, A3, and sum of x2 is B1 plus B2 plus B3. So now let's look at each of the 3 parts. A1 is equal to B1, right? There is no doubt about that because both the halves are same. What about A2 and B2? A2 has been replaced by x2 in the second case, but in the first case it is as it is, right? So can I say that A2 is greater than B2? Can I say this? Right? Everyone understands this because I have replaced it with a smaller number, x2. Previously, it was a bigger number. And then you can say for A3 and B3 also. A3 is x1, A3 is x1 and B3 is x2. So straightforward, A3 is greater than B3 because A3 is all x1 and B3 is all x2. So then you can simply say that A1 plus A2 plus A3 is greater than B1 plus B2 plus B3, right? So S of x1 is greater than S of x2. Right? Yes, Suraj. So for A2 and B2, just think about why you replaced this thing with x2 because it was less than x2, right? Because it was greater than x2. So a set of numbers which were greater than x2, you have replaced it with x2. So the original set of numbers, the sum of that will be more than the sum after replacing it with x2. Yeah, so sum is basically greater than, so as you increase x, your sum increases. So the point here is that you have to find the smallest, right? So you have to find, and so there will be a threshold. Your threshold is here somewhere, and there will be an x for which it will cross the threshold. So what you have to do is you have to tell me this x for which it is less equals the threshold, the first x. I mean the last x basically here, going from here. Okay. So now let's look at the pattern. The pattern is similar, right? It's an optimization problem. It's an optimization problem wherein you have an x which you have to minimize, an x which you have to maximize, right? You have to return the largest x for which Sx is less equals t, correct? Can I say that that is the problem that I'm solving right now? Can I say that the actual question is equivalent to me finding the largest x such that Sx is less equals t, right? So I have to maximize x such that sum fx, what is that fx? Fx is the sum, nothing but sum after substituting, is less equals t. So doesn't this follow the pattern that I was talking about? So you can apply binary search on it. That's the first conclusion. Then once you know that you can apply binary search on it, let's look at the search space. So potentially, which part, Rahul? I just looked at the pattern and I concluded that binary search is applicable, right? Because I have to find the largest x such that the sum is greater, less equals the threshold. So now I will have to find my search space. So now my search space trivially is 1 to infinity, right? 1 to infinity or 0 to infinity? Why not 0? That's because the target is from 1. The reason why 0 is not needed is because the target, if you see, the range is from 1. If you take 0, you will be replacing all the elements of the array with 0 and your total sum will be 0, right? And but you want to find, so that is not really needed in the search space. Yes, it's not because the numbers are from 1, but it's because the target is from 1. So 0 you don't really need in the search space, because for 0 your sum will anyways be 0, which is still less equals threshold, right? I think 0 is also there in the search space, right? Why do you want to remove 0? Yeah, I think 0 will be in the search space. Okay. Now let's do the second part, which is basically trimming the search space. So how do I trim the search space? Let's try and find the upper bound for this search space. What is the upper bound? Can you tell me? Max, right? You cannot go beyond max at any point. If you replace it by max plus 1, then also you will be And in this case, what will be the sum? The sum will be the sum of elements of the array, right? Because you will not be replacing any number. And this is redundant. What about the lower bound? Can I say my lower bound is from minimum AI? No, right? Yeah, the lower bound will still be from 0, Tanya. It won't be from minimum AI. Yeah, so this is your search space. And now let's talk about the predicate. So I have to find the largest X such that, so I know that as I'm going in this direction, my sum is also increasing. So I have to find, my threshold is somewhere here. I have to find the X, which is the largest X, which is less equals threshold here. So can I make it false here and trues everywhere else after this in some way and find the last F, right? So what will be my predicate? Sum greater than the target. If I use this predicate, then I have to find the last F. So once I get the last F, let's say this is S1. Let's say this is X1. I will find SX1. And then I will also find S of X1 plus 1. And I will take the absolute difference of these two and take the minimum. Right? So this will be T minus S of X1. Another one will be absolute of T minus S of X1 plus 1. And this will be my result. Right? Shall we code it, or do you want to code it on your own? Sai, that result line stems from the fact that in the question you have to find one such X which is whose absolute difference with the threshold is as low as possible. So it can be one on, so basically it can be, so you know that for X1, your sum was less equals the threshold, and for X1 plus 1, your sum will be greater than the threshold, right? Your threshold is somewhere here. I mean the threshold for the sum. So this difference and this difference I am taking, and I am taking the minimum of these two. Because it can be this also, it can be this also. Yes, it will be the first T, correct. Yeah. You can do that also, but there's no point. You already have the last step.
Sir, how is 0 included in the search space?
How is 0 included in the search space? So why will 0 not be included in the search space? All integers are possible, right? So if you take 0, you will replace everything with 0, correct? Because all the numbers are greater than equals to 1 in the array. It's given. Is it given?
Yeah.
So the sum is 0 and it is still less equal to the threshold, right? If the threshold is 1, then 0 can be the answer, right?
Okay.
Threshold is not greater than 1, it is greater or equals 1 in the question. 0 can still be. Okay. Do you want me to code it or are you coding on your own? Okay. You can try it on your own. And if you don't get it, we can discuss. Is that fine or do you want me to code it? Or I can give you 2 to 3 minutes. You can try it. Okay, I'll give you 2 to 3 minutes. Others also are coding, right? Try it. And I guess they're coding. That's why they're not replying. So Sarad, read the question. The question is telling you to find the number for which the sum, this is the threshold. You have to find the number for which the sum gets as close to threshold as possible in absolute difference terms. So it can be a number for which the sum is less equals t, or it can be a number for which the sum is greater equals t. So what I am doing is I am finding that x for which the last x or the largest x for which the sum is less equals t, and I am finding the sum for x plus 1 also. So sum of x plus 1 will definitely be greater than t, right? Because this is the last f. Right, Sarath? Do you understand this? Yeah. And then basically I'm just saying that I will, these are both of them are my potential candidates, x and x plus 1. So how do so I can simply check the absolute difference and see whichever absolute difference is less, I can return that corresponding number, right? So I can take t minus s of x. This is one number and the other number is s of x plus 1 minus t. So whatever is the minimum out of these two, I can return, right? Do you get it? Sarah? No? Yeah. Okay. Cool. Did you accept it, get it accepted, Subha? Cool. Shall we start? Others? What about others? let's start. Not this screen, I have to share the other screen. Okay, let's do this here. So first things first, I will write the compute the predicate. So how do I do that? I will have to find the sum, right? So let me do a get sum, or my function was s, I've been using s. So this is for one value. So how do I change? Simple stuff. I will need the sum, which is 0. If my array I is greater than the value, then I can sum value. Otherwise, I can sum array I itself. Right? This is the way I can get the sum. Right? Now let's come to the meat of the code, which is let's first find the maximum. So that will be my high. The same type of code. I can find the minimum, maximum. Then what I will do is int t1, t2. Let's see. First, I will get the x for which so low is pass. So low is 0, high is maximum. So let's come to this, and then we will come to finish the remaining part. Now I will return the x, the largest x for which s of x is less equals target. This is what my binary search will do. I will take the low and the high. I will take the target. Now I know that it is an f star t star predicate. And I have to find the last f. For which predicate? For predicate dx s of x is less equals target, right? Or greater than the target, right? So let's do this. Then there is a mid. While we'll go, I don't know how to compute the mid. But first I will take the decision. If P of predicate at mid, right? What is the predicate? S. S mid is greater than target. So if it is true, I can skip this. Otherwise, I have to keep it. Mid will be dictated by this term, so it's a high. Now the sanity part. So if I come here, I know that it is less equals the target, right? I don't know. It can be greater than the target also. But I don't care. Let it be. It can be the greater than equal to the target also. Let's just return it. Okay. What I will do is now I will compute the sum for T1. So, okay, let's go by the convention. This is X. This is X. Let's compute the sum for X. And let's compute the sum for X plus 1. And let's return the minimum of absolute difference of T2 minus target T3 minus target. What is wrong? I have to return the integer. So I don't have to return this. I will have to do an if else then. That will make the code dirty. So this is less. In case of tie, you have to return the smaller. So if this is less equal, then you can return X, else you can okay. Now ask me questions if you have any. This is the code. Why did I not do a sanity check here? It can still be greater than T, right? It can still be, I have to find the last step. So it can be still be a T, right? If it is all T's, why didn't I check that here? See the code, Akash. It's the same code as the last class. I mean, the last problem. There's not a lot of things that has been changed. Ask me questions quickly if you have. Don't hesitate. I will explain every. Do you understand this part? This is just computing the sum. This is basically the predicate that we finalized, and I'm finding the last step. The only part mystery is why I didn't do a sanity check here. That's the mystery. And then this part is little different, wherein I am checking for X plus 1 also. The question doesn't consider negative numbers. You can, Tanya, technically, but 0 will always be the answer in that case, right? Right? Did I make sense? What I'm saying is, let's say your search space also considers negative numbers. Then in that case, since the threshold starts from 1, for all those cases, 0 will be the answer, right? So you can trim them off. Yeah, that's a good question actually. Why didn't we take negative numbers in the search space? We could have started from minus infinity to plus infinity, right? Why did we just start from 0? Nobody? Are you guys there? The question says target is greater than 0. If you see the constraints, target is between 1 to 10 to the power 5. See the constraints, this. Yeah, it's a comma. Yeah. Okay, ask me questions if you have any, otherwise we'll move ahead. Is there anyone who has no idea what's going on here? It's okay to speak up. Everyone has some idea. Why didn't we do a sanity check here? I have 2 questions for all of you. Number 1, why didn't we take negative numbers in the search space? The second question is, why didn't I do a sanity check here?
So the negative because the target is anyway greater than or equal to 1. So let's say take -2 and -3. That'll give the same result, right? Because the target is anyway, the condition is always satisfied for negative numbers.
Yes. So why didn't the condition is satisfied? That's true. But why didn't we take them? Because don't you think in those cases 0 will cover for them? 0 will cover for them. Because I have to find my question is I have to find one x for which Sx is the largest x for which Sx is less equals the threshold, right? So Sx will be less equals the threshold for 0 also, for negative numbers also, but it will be less equals the threshold for 0 also, always. Why? Because the threshold is greater than 1, greater than or equal to 1. So in all those cases, you will have 0 as the answer, at least 0.
Can you explain again why exactly negative numbers with the example? Because
yes, I can. See, I am telling you that if you take any negative number, let's say -3, your numbers in the array are greater equals 1, right? It's given. So you will potentially replace all the numbers with -3 then, and your sum will be negative, right? For a negative number. For 0, your sum will be 0 because you will replace all these numbers with 0. So your sum will become 0. You have to give me the largest x for which S of x is less equals threshold. That's what we are looking for. right? And threshold itself is greater equals 1. So for all these negative numbers, aren't they useless? Like they are not really needed, because 0 will at least be the answer for all those cases. Because for these numbers, the Sx will be less equals t, but so will it be for 0 also, for any threshold. So any answer, so you can prove by contradiction. If you want to really prove by formally, you can prove by contradiction. You can say that, let's say a negative number is my answer. Okay. So then you will say that if a negative number is my answer, my sum is also negative, correct? And because a negative number is my answer, this sum is also less equals threshold. So now you say that, okay, now let's take 0. 0 also the sum is less equals threshold, correct? So this negative number cannot be the answer. This cannot be the largest such number.
Got it, sir. Got it.
You can prove it by contradiction if you really want. No sanity check, because 0 is guaranteed. Replacing everything in 0 would give some 0. Yes, that's also one way to. That's a good answer actually. You will at least have one F, right? So you can guarantee that, because you are starting with 0, you will have, because you are starting with 0, you will have at least one F in the search space. So it will not really be all T's ever. Correct? What was your predicate? Your predicate was sum greater than T. It will not be all trues ever, because at least for 0 it will be satisfied. So there will be at least one F. So you can skip it. Make sense? Do you get this? Why not sanity check? Yeah. Why is the participation so low today? Are the questions difficult, or are you trying on your own, or are you not understanding? Or one or more of these? Like generally the acknowledgements, yes or no, either way is more. Okay. Cool. Shall we move on? All done? Everyone done? Do you understand things? Okay. Let's do another question. I like this question because there are bananas here in this question. Do this question. I can show the code, Tanya. Where is the code? This is the code. You want me to reduce the font? Because I have to return the x and not the sum. I cannot return the difference, right? I have to return the x, not the sx or the sx minus t. Utkarsh, hello, are you there? Utkarsh Tiwari? This is your first class, right? Are you following? Is it getting difficult? You have no idea what's going on.
No, no, sir. I attended your different classes like in DSP 3. So I have some idea of this thing. So
Okay. You were in DSP 3, right?
yeah. I got that batch shifted. So
All right.
so I'm able to understand. Yeah.
So you're able to understand, right? Okay,
Yes, sir.
cool. I just thought that you joined today, so you must be like going nuts. What's going on?
No, sir.
Okay. Coco eating bananas. I like this problem because there are bananas in the problem and I love minions. So Karan, did you have dinner? Are you hungry? No, it will disperse and then you can have. This is like the first question of today. In piles of bananas, the ith pile has piles I bananas. Okay. The guards have gone and will come back in HRs. Coco can decide her bananas per hour eating speed of K. Okay. Each hour she chooses some piles and eats K bananas. If the pile has less than K bananas, he eats all of them instead and won't eat anymore. Minimum integer K such that she can eat all bananas. We can calculate time for every value and when it reaches less than h. That is the answer. For every k you mean, right? Her speed, yeah. Yeah, that's precisely what we will be doing. But is she allowed to eat from the same pile again? Let's say if that pile had more than k bananas, she can eat again, right? It's just that, right? It's not binary that you have to finish off that. Is it Mantavya? Is it the case that she can eat from the same pile again? So what is the question? Shall we start, or are you guys still doing it on your own? Looks like everyone's occupied doing the question. Yeah, do it. That's the question that I was asking. If the banana is greater than k, can she eat the leftover bananas in the next round? Yeah, I think so.
Yes, sir. Yes. She will be eating in the next hour
Yeah, in the next hour.
because they mentioned wouldn't eat any more bananas during this hour.
Hmm. Minimum k for which h into k is greater than sum of array. Is that? No, for a particular k, you will have to find out how much hours it takes for Coco to finish off the bananas. Is my analogy with the first question correct? First question was of the threshold divisor, right? You were dividing it. Actually, yes, I think Ankit is absolutely correct. It is nothing but the first question. Yeah, Ankit. Yeah, it is the same question. Right? Does everyone understand why? Isn't it the same question as the first question? Yeah. Right? So, shall we move on? You can try it at your home. Let's move on. It's the same question. I will give you one question which we can do it today, and then I will give you one homework question which will be a harder question. But let's do this first. So how do we do this question? Are you guys doing question? Which question are you guys currently doing? COCO or the ship capacity to ship? Or are you not doing any of them? Do you want to do these at your like on your own? It's the similar question. I can, okay. I'll give you, maybe we will discuss this question. And people who have done this question also, I can give you another tougher question. But yeah, let's do that first. You want to do another question? It's a tougher version of this. So shall we start? Okay, everyone's engrossed doing the question. That's a good thing actually. Did anyone get it, I said? Okay. So here in the question, what's given is first index to sum of all elements. We will see, Rahul, what really will. So in the question, it's given that you have a bag, you have a conveyor belt, let's say, which has items which are coming in. Each item has a certain weight. Okay. You have a ship of certain capacity C, and what you are doing here is that every time you can load the ship to its maximum capacity, and then you will go and drop it to the destination and come back. The only constraint here is that you cannot load a package in fractions. So you cannot load half a package. You will always have to load one complete package, at least one complete package. So you have to find the smallest C such that you are able to transport all these weights within D days. You have a D given. Right? One example, if I were to give you, let's say this is 3, 4, 2 and 1, and let's say your ship is of capacity 5. So what you will do is you will first load 3. Now you cannot load 4 because the sum will become 7. You will go and come back. So that's one trip. Then the next trip you will load 4. You will go and come back. You cannot load 2 because it becomes 6. So that's another trip, 2 trips. In the next trip you can load 2 and 1, both go and come back. So in all you need 3 trips for this capacity. So you have to, obviously, as the capacity of the ship increases, the number of days that you need or the number of round trips you need will decrease, right? As the capacity increases, the number of round trips will decrease. And so you have to give me the smallest such C for which your R is within D. So basically, as you are increasing the C, your R is decreasing. So there will be a point when your R becomes less than a given number D. And the first time that R becomes less than that D, that C you have to give me. Right? Does everyone understand the question? Hello? Yes, Sai. What part do you not understand in the question, Sai? So if you see, this is also one such question wherein, yeah, so this is what I'm saying is, as you increase the capacity, your round trip time, your number of trips that you need will decrease, right? This you understand? So there will be one capacity for which that, so basically you think about it in this way, that as you keep increasing your capacity, as you go from, see from this graph, as you keep increasing your, so it's decreasing. So as you keep increasing your capacity, there will be a point when your trip will cross D, the trip, number of trips. And that is the C that you have to report. Correct? Yeah. And so this is also similar. If you see the pattern in this question, you have to find the smallest capacity C such that f of C is nothing but the total number of trips that you will need. F of C becomes less equals D. You have to find the smallest such C. So isn't this an optimization problem where the constraints are of this type and you have to optimize a value? Okay. So let's talk about the search space then. So the search space in this case, if for this capacity will be, what will be the search space? If I take it from 1 to infinity, let's trim. It will be, let's talk about the lower bound. You cannot have anything less than the max of AI, right? Because you cannot transport any package in fraction. So these capacities will definitely not be applicable to the problem, right? And for the upper bound, if you take anything if you take the sum of the elements, then that's the upper bound, right? Here you will take one trip. Anything after that, if you take capacity, that also will take one trip. So this is redundant. This is redundant and this is not applicable. So your search space is from max of AI to sum of AI. Is there any question on this? The trimming of the search space? Do you get this?
Can you repeat this search space?
Yeah. So the point here is that if you have a package, you can only transport a package as a whole and not in fractions. So you cannot have a ship of capacity less than the largest number in the array, right? Because if you have that, then you cannot transport the largest package at any cost, because you cannot break a package that's given in the question. Every package you have to transport as a whole. It's not that you can transport half package now and half package in the next trip. So that's why you cannot. So that's why this maximum, and the minimum is, I mean, the upper bound is basically if you take the sum, then you can load everything at once and go and drop it. That's just one trip. If you take anything more than that, then also it will take one trip. So that's basically the upper bound. Right, Sarath? Do you understand? Yeah, everyone understands this? This maximum to sum. So now tell me the predicate then. If I have to do an F star T star, total trip time, let's say total trip time is T. I will have to find the total trip time for every capacity, right? For I have to fix one capacity. For that capacity, I will have to find the total trip time. That's okay. But can I say that total trip time for this capacity C
is less than D?
Is less than D, you are saying. So it will be false as you increase C, and there will be a point when it will cross. Okay. And you have to find the first T, is it? With this? Or the last F? Yes, Suraj? First T or the last F? last F. So as you increase the, so will this give me an F star T star predicate? This is a predicate that has been proposed by one of the person, by Suraj. Is this correct? Is the question. So as you increase the capacity, your trip time will decrease. And there will be a time when the trip time becomes less than D. Do we have to use this or the equality? Which one? Why are you getting confused here? Yeah, we'll have to use the equality and find the, what do we have to find if we use the equality? The first T, right? Yes, this is the correct answer. Okay. So let's get to the act of coding then. Cool. Is everyone on the same page?
So can you explain how exactly is the first T and it is not the last F?
Because you understood equality. The equality is there because see, for small c's, it will be F, and then there will be one C for which it will maybe become equal to D, maybe or may not be. And then after this, for all the other C's, this will become greater than the D, right? You have to find the smallest such capacity. So for this, it becomes less equals D, right? And you have to find the smallest such capacity for which you are able to do it within D days or after D. What is the question exactly?
Within D days.
Within D days. Then this is not right, is it? If you find the first T, yeah, I mean, yeah. If you find the first T, for the first T, this will be the equality that will hold, right, Suraj? So this is the first C coming from the left, which means this is the smallest C for which the time is less equals T. So this is the smallest for which you can transport it within D days. You can transport it within D days for this also, for this also, for this also, for this, but you cannot transport it within D days for this, or for this, or for this.
Understood.
If you take TC less than D, it's not right. Why? Because let's say you are going with the first true, it can be within D days, but if this F is equal to D, for this F, if TC was equal to D, then this would have been the answer. Right? So if you choose this predicate, then your last F or the first T can be the answer, which you don't want. There shouldn't be any ambiguity in that.
Yes, sir.
Not that you cannot solve it, but you don't want it. So yeah, that's it basically. Now, so shall we code it? Okay, just follow along. Let me just open it up. So this is the screen. Let's first calculate the trip time. Okay, as we've been doing all this while, let's first calculate the trip time and get trip time, or let's just say this is T. We've been using that. So for these weights and for a particular capacity C, I need to find the trip time. Okay, let's see how to calculate that. So what do? I keep a running sum. Okay, this I think we have done this in the basics in the first question, and if I check if the current sum plus the weights of I is becoming greater than C, then I can increment my trips, right? Then I can increment my trips and I can change my current sum to this or 0, let's say, and yeah, right? And finally, for the last element, I can simply return plus trips. I have to increment my trips by one more. Is this function clear to you? What I wrote?
So or we can just start with you can say trips is equal to 1 in the beginning itself instead of
Okay.
return plus trips, because minimum one trip will anyway be there at 1 day minimum. Then we don't need to account for the last case, I think.
Yeah, that's also okay. So plus trips is for the last package. For the last package, this check has not been made, right? So let's say you have been accumulating weights in the current sum, and at the last index also, even at the last index, if this became equal, you have one current sum equals to weights I, right? I mean, at least equals to weights n minus 1. The last trip you have not accounted for in this for loop because of the strategy. What is the strategy? You are counting ahead of time. Yeah, it will still ship. The array need not be sorted. Okay. So I'm not accounting for that, Ankit. Why do you think is that? This is fine, right? Okay. And then let's do the second part, which is, let's write the binary search first, and then we can call it from the driver function. Okay. So let's do int binary search. Let's pass the D, let's pass low I and the D. So I need the mid. No, Tanya, this is right? If it is, if you can tolerate capacity C, right? If the array is this and C is 4, no, Ankit, why should it be 2? It should be 3, right? For your example also. First trip it will take the 3 ones. Second trip it will take the 4. No. It's not out of place. It's one after the other, the packages. It is one after the other. It's like a queue. It's coming. It's a conveyor belt, right? You cannot just pick up an item from the middle. Yeah. Tanya, this is correct. For less equal C, you can still be okay. As soon as it becomes greater than C, you will have to increment the trips by 1. So let's do this. While low is less than high, I don't know my mid, but it will be something. We'll come to that. Let's do the decision making, which is predicate. Okay, let's write that. I want an F star, T star. My predicate is nothing but trips of X is less equals T, and I have to find the first T. So the predicate will be if T of weights with the capacity, with which capacity, with mid, right, is less than or equal to D, then it's a true, right? So you cannot skip this. Otherwise you can skip it. This will dictate the mid, so your mid will be low mid. And what is the sanity check? Once you come out, if it is a false. Here also, I think you can always guarantee that you will get a package, right? You will have, at least when for the sum, you will have Tx less equals D, because D is greater equals 1, right? And for D1, when is D1 possible? When you have capacity as the sum of the weights. So here also you don't really need the sanity check. Now let's write the driver function. So I will find the ranges. So first I will find the maximum. So let's find the maximum and the sum also, right? Sum is 0. Maximum is and your sum you can just add, right? And then you can, what do you have to return? You have to return the least weight capacity, right? We are searching for the capacity only. So you can simply call return binary search weights low, high, and D, right? So low is your max num, high is your cumulative sum, and D is D. This is the code. Okay. Do you follow? Any doubts in any part of the question? Anywhere? No, right? So are you getting a hang of how to do these kinds of questions now? Not very tough, but not very easy also, I understand. But with practice, you can master this, like all things in life. Okay. Shall we move on? Is it becoming too much for the day? Yeah, we can do a puzzle. We have a puzzle also in place. So let's do this puzzle. So pretty much binary search is done. And yeah, let's do a puzzle. Let's do this puzzle. This is a relatively difficult puzzle, but yeah, you can do it. So a king has 1,000 wine bottles that he got. I don't know how you draw bottles, but yeah, I'm very bad in drawing. A king has 1,000 wine bottles and thousands of them, exactly 1,000 wine bottles. And what has happened is one of these bottles is contaminated. It is contaminated with poison. So the king employs a strategy. The point is that once a person drinks from this bottle, it takes at least 4 weeks for the poison to start having an effect. So the person will only be dying after 4 weeks. Okay. And the king has exactly 4 weeks of time to find out the bottle which is contaminated. You have to tell me how many minimum number of his servants how many minimum number of servants should he engage in this task so that he can find out after 4 weeks that find out the bottle that has been contaminated. Do you get the question? Should I repeat? So there are 1,000 wine bottles. One of them is contaminated, and the king wants to find out which bottle is contaminated. An attendant or a servant can drink from any of the bottles. There is no harm in that. You have to tell me, but obviously he will die after 4 weeks. And the king needs to know within 4 weeks, like immediately after 4 weeks, that which bottle is contaminated. So you have to tell me how many minimum number of servants should he employ to find that out. Like 1,000 is obviously everyone you tell to drink. And once you tell everyone to drink from one bottle, yes, you can find out the servant which died, that bottle. Yeah, the same bottle can be drunk by two people. That should be fine. And even the person can drink from multiple bottles. But if he has even one drop of the contaminated bottle, he will die. Yeah, others, people who have done it, it's fine. So I will tell you the answer. The answer is 10. Can somebody tell me the strategy? I can also tell you that answer is actually log n, generally log n to the base 2 for n wine bottles. Can you tell me why, or can you tell me the strategy for this?
Like we have used in probability for
Okay.
finding a tossed coin,
Mm-hmm.
we will use that same pattern. Either he will die or not die. We make the pattern and give wine bottle to a 10, like make pairs of 10 people, like 10 bottles choose who will die or not in that pattern.
Yeah, I mean, what you can just assign binary numbers to bottles. So see, bottle number 0, you can number the bottles from 1 to 1000. So bottle number 1, 5, 6, 7, 8, 9, 10 is the binary representation is this. Bottle number 2, the binary representation is this. This is for 3. This is for 4. This is for 5. This is for 6. This is for 7. This is for 8, and so on. So now what you do is you tell this is servant 1, this is servant 2, and so on till servant 10. So you tell the 10th servant to drink from all the bottles for which the least significant bit is 1. So tell servant 10 to drink from this bottle, bottle 1, bottle 3, bottle 5, bottle 7, and so on. Tell servant 9 to drink from bottle 2, bottle 3, bottle 6, bottle 7, and so on. Tell servant 8 to drink from these bottles, and so on. Okay. Now, one of the servants, like there will be many servants who will die. Which servants will die? So let's say this is the bottle that is contaminated. So all those servants will die for which the respective bits were set to 1. Right? So then you can just put them in a line, and so put all the servants S1, S2 to S10 in a line. The servants which died, put a 1 corresponding to them, and servants who didn't die, put a 0 corresponding to them, and convert it to decimal. This is the bottle number. Right? Do you understand? Is there anyone who does not understand what I did here? Yeah, sir. So do you understand the assigning scheme? Like how am I assigning servants to bottles? I am telling servant 10 to drink all bottles with the least significant bit set. I am telling servant 9 to drink all bottles with the second least significant bit set. Servant 8 to drink bottles with the third least significant bit set, and so on. This part you get it right, Sharad and Rahul? Sharad and Rahul, do you get this? 10 is the minimum, Sharad. That's the... So there will be 10 bits to represent 1000 bottles, right? How many bits will be needed to represent the numbers 1 to 1000? All the numbers? 10 bits. Because 2 to the power 10, right, is 1024. You understand this? Yeah. So that's why we have 10 servants. And every servant you can give the corresponding bits, and then for that contaminated bottle, you know which servants died. So put a 1 for them, and for the others put a 0, and that number is the bottle number which is contaminated. Right? Do you get it? Yeah. Okay. So this is also a good question. This is, if you see a pattern, the reason this works is because this is the least, like the smallest possible base 2. We operate in base 10, which is decimals. This is the smallest possible base 2. And that's the reason why this is, this works. Or rather this is the minimum. That's basically the intuition. Okay. So that, I mean, brings us to an end to binary search. Do you have any questions around binary search? These 2 types of questions we will typically encounter in binary search. I just told you we practice problems on both the types using the predicate framework that I gave you. Right? Do you feel comfortable now in somewhat in binary search, although you will need some practice? Yeah, you will need some practice obviously, but somewhat, right? At least now you don't have to break your head over those corner cases and yeah. Okay, so if you see the timeline from tomorrow, we have Web 101 tomorrow by Varun. So he will be taking the class. We will have a doubt sessions separately for DPP1. I will send out the second DPP also, which has all questions from searching and sorting. You can just do the searching questions. Sorting will be covered after 2 pointers. So tomorrow Varun will take 1 class and then Sunny will take 2 classes on 2 pointers. 2 pointers will be really good for you. And that also helps clear up a lot of concepts. And yeah, if you have any questions, I'll be happy to answer. Otherwise, yeah, from my side, I am done. I just gave you 1 question, which was try this question. We can discuss it later. This is a relatively tougher question. I will paste it on Slack also, but you can try it. H index, Sasank, we can discuss. Yeah, I mean, we're planning to have 1 doubt solving session for binary search also. Okay. By the way, what is the problem that you're facing in H index, Sasank? I thought that's a straightforward question.
So like, don't know exactly how to approach the problem because the answer doesn't lie within the array, so it could be anything.
Mm-hmm.
So that's where I have it out.
Okay. Okay, we will discuss that. I mean, we have done questions today, right? Even today we have done questions where the answers don't lie within the array, but there is a search space.
But this is binary search only, right? Or I'm not.
I don't
It's
remember
not exactly.
This is not truly binary search. Yeah, you're right. But I will have to see. I will have to read the question also. I don't remember this. Okay. But yes, we can definitely discuss. I'm not saying I'm not discuss it. We can discuss it sometime this weekend itself. Okay. Either on a Saturday or a Sunday. Cool, Shashank? Okay. I mean, all of us, the entire batch. Any other questions for me?